Hello friends, welcome to another video of Zeta Axis, and today we will discuss about ozone layer and the causes for depletion of ozone. So we can see that ozone is a very small fraction of our atmosphere, where the oxygen is around 22%, nitrogen is around 78%. We can see that this fraction is very less. It is even smaller than argon or carbon dioxide. So basically ozone forms a very small fraction of our atmosphere, but it plays a very important role in our atmosphere. Now if you look at the distribution of ozone in our atmosphere, then we can see that the maximum concentration of ozone is found in stratosphere. In fact, in the lower stratosphere. This is the region where there is maximum ozone. When we go in the troposphere, we can see that some amount of ozone is formed over here, but here it acts as a pollutant. The ozone in the stratosphere absorbs UV rays and protects the life on our Earth. But the ozone in the troposphere, it acts as a pollutant and causes photochemical smog. We will discuss the ozone in troposphere in another video. In this video, we will only confine ourselves to stratospheric ozone. So we have already seen that ozone absorbs UV rays, but there are three types of UV rays: UVA, B and C. Out of all these UV rays, the UVC rays are the most energetic and most harmful to life on land or oceans. So our ozone completely absorbs the UVC rays. It partially absorbs UVB rays, while it does not affect much UVA rays. So you can see that the UVA rays completely pass through the ozone and reach our Earth, but they are less energetic compared to these two. Now we have seen that ozone in troposphere acts as a pollutant and it causes photochemical smog. Here you can see an example of photochemical smog. Now if we look at the process of formation of ozone, we can see that both in stratosphere as well as troposphere, the ozone is formed via different mechanisms. In stratosphere, the ozone is formed by photodissociation of oxygen molecule. A UV ray coming from the sun, it breaks the oxygen molecule into oxygen ions. This oxygen ion combines with oxygen molecule to give ozone. We will see this process in detail in coming slides. The tropospheric ozone is formed by reactions between two primary pollutants. The first is VOC and the second is nitrogen oxides, and it is the reaction of these pollutants that gives rise to ozone in troposphere. And remember, ozone in troposphere acts as a pollutant. Now here we can see the atmosphere in stratosphere. We can see that there are these red molecules, these are oxygen, and these are green molecules which represent the ozone. These yellow color lines, they indicate the UV rays which are coming from the sun. Now we can see here that the concentration of oxygen is much larger compared to the concentration of ozone. Now these UV rays which are coming from the sun and they are very energetic, they may collide with oxygen molecules in the stratosphere, but oxygen-oxygen bond is very strong. So it does not break quickly, but every now and then an energetic photon will break this oxygen-oxygen bond. Now the oxygen ion which is released, it will combine with another oxygen molecule because the concentration of oxygen molecule is large here. Therefore, the probability of an oxygen ion combining with an oxygen molecule is high. So we see that it will quickly combine with a free oxygen molecule and it will give ozone. So we can see how this ozone is formed. Now remember, the process of breaking down of oxygen molecule takes time. So it is a slow process. This ozone molecule bonds are weak. Whenever a simple photon will hit this ozone, the oxygen ion will detach and it will give us an oxygen molecule and a free oxygen ion. This oxygen ion will again combine with another oxygen molecule to give ozone. Now again the ozone bond is weak, so we will see that the photon will again hit this ozone and we will get a free oxygen ion which will again combine with another oxygen molecule to give us ozone. So this process is repeated in a very swift manner. In fact, within a matter of hours, the whole ozone molecule in a layer can change. So you can see that this is a very fast reaction. And we can see here that there is an oxygen molecule which combines with oxygen ion to give ozone. Now this ozone then again combines with a photon and then it releases this oxygen molecule and gives an oxygen ion. this oxygen molecule is again recycled and this process continues. So you can see that this is a cyclic process. The output of this reaction is used in this reaction and the output of this reaction is used in this reaction. So we see that this process of formation of ozone and then again destruction of ozone by a photon into oxygen molecule continuously goes on. This is a cyclic process. We have already seen that the ozone bond is weak, therefore it breaks easily by sun's radiation. That is, whenever a photon collides with the ozone molecule, it will break into oxygen molecule and oxygen ion. We can see this reaction over here. Now this oxygen ion is very active. So it will again quickly combine with an oxygen molecule. Remember, the concentration of oxygen molecule is higher compared to the concentration of ozone. So the probability of this oxygen ion combining with an oxygen molecule is higher. Now sometimes what happens that this ozone will get dissociated. It will give a free oxygen ion which may combine with ozone. And now this ozone will break into two oxygen molecules. We can see that one oxygen molecule is over here and the other is over here. And this is the process which takes time because the concentration of ozone is less in the stratosphere. Therefore, the chances of an oxygen ion combining or reacting with an ozone molecule is less. Therefore, this process takes a lot of time. If we see the reactions, we can see that here the ozone molecule combines with an oxygen ion to give us two molecules of oxygen. Now remember, which we have discussed, ozone concentration is very less. Therefore, the chance of this reaction is less. Now let's try to understand this same mechanism in another way. We will use different mechanisms to understand this process so you could understand how this ozone is formed. So here we can see a vertical collection of oxygen molecules. We can see that there are oxygen molecules in these vertical columns and then there is an ozone molecule column. Now suppose a photon dissociates this oxygen molecule into oxygen ions. You can see that this process is a slow reaction process. But the oxygen ion which is formed, it will react with the other oxygen molecules and form ozone. We can see these green molecules are ozone molecules. Again, they will dissociate and they will form an oxygen ion which will combine to form another ozone molecule. And this process goes on continuously. Sometimes the oxygen ion which is created, it may combine with the ozone molecule and give two oxygen molecules. So here we can see that this is the process by which the ozone is destroyed naturally. Now if we try to understand this reaction via a graph, then we can see here that there is an oxygen molecule. This oxygen molecule gets dissociated by a photon and it gives us an oxygen ion. This oxygen ion combines with oxygen molecule which is there in the atmosphere. And this reaction is a slow reaction, but it will give you a ozone molecule. Now this ozone molecule can be broken by another photon and it will give us another oxygen ion. This ion will again combine with a molecule of oxygen in the atmosphere and give us ozone. This is a cyclic process and you can see that both of these reactions are fast reactions. Therefore, this process of formation of ozone as well as destruction of ozone continuously goes on. But sometimes you will see that this free oxygen ion will combine with another ozone molecule. Instead of combining with this oxygen molecule, it may find and react with an ozone molecule, thus giving us oxygen molecules, two oxygen molecules. And this reaction is slow reaction. Therefore, the process of formation of ozone from this O2 molecule as well as destruction of ozone is very slow, while this cyclic process is very fast, and this keeps a natural balance. But because of halogens like chlorine or bromium, this natural balance is disturbed. So we will see in the next part how chlorine or any other halogen disturbs this balance. So here we can again see that there are ozone molecules and there are photons which are colliding with them, but there is a chlorine ion over here. Now remember, the chlorine has high affinity for reaction with oxygen ions. Therefore, the oxygen ions which are released from here, they will react with this chlorine and form ClO compound. Another oxygen ion which is released from here will react with this ClO. And what we will get? this chlorine will be released and we will get an oxygen molecule. So you can see that the oxygen ions which were released from here, instead of forming ozones by combining with other oxygen molecules, they reacted with chlorine and they formed ClO. Another oxygen ion came and now chlorine is free and we get another molecule of oxygen. So this chlorine inhibited the process of formation of ozone, and we can see that chlorine will continue to do this. We can see that it collects the ions, oxygen ions, and then combines them into oxygen and then sets itself free. So this process continuously goes on in the ozone layer, and we can see that wherever the chlorine was present, there is no ozone left. Only in the regions which are far away from chlorine, we can see that normal reaction is going on. So this is exactly the process by which the chlorine destroys the ozone. One chlorine atom can destroy these many, that is 1 lakh ozone molecules. So you can see that before a chlorine could be removed, a single chlorine atom can destroy these many chlorine molecules. That is why chlorine is a serious threat to ozone. The chlorine acts as a catalyst that we have seen. It captures a free oxygen ion and converts them to oxygen molecule. Chlorine itself is not consumed in the process. Therefore, once it has created one oxygen molecule, it will go again, it will combine with oxygen ions and again create another oxygen molecule. It will continuously use this oxygen ion, which could be used to form ozone. So far we have seen how chlorine destroys the ozone. But there is a mechanism by which this chlorine is naturally removed from atmosphere. Now, understanding this process is important for understanding the reasons for formation of ozone holes in Antarctica. Now we know that there are different gases in our atmosphere. They are in very small fractions like methane or nitrous oxides. Now every now and then this chlorine will come in contact with methane. It will react with it and form this hydrogen chloride, which is a stable compound. Similarly, it can come in contact with NO2 and we will again get a stable compound. So these two compounds in the atmosphere act as a stable compound. They do not release chlorine back into the atmosphere, and that is why they are called chlorine reservoirs. Here is the general reaction between chlorine and these molecules, but this is not required as per the exam perspective. So here we have seen that how chlorine is naturally removed from the atmosphere by forming them or converting them into very stable compounds which do not release this chlorine back into the atmosphere. Now let's try to understand the effect of chlorine in ozone formation process using a graph. So here we can see there is ozone which is photodissociated by a photon. It gives us an oxygen ion and an oxygen molecule. Now this oxygen ion reacts with chlorine to form chlorine oxide. This chlorine oxide will again react with another oxygen ion which comes from another ozone photodissociation. So we can see that this oxygen ion reacts with this chlorine oxide and it gives us two molecules of oxygen as well as we get our chlorine free. Now you can see that in this whole process, ozone is destroyed. There is no output of ozone. There are only inputs. These two are input points for the reaction. In the outputs we get oxygen. So this process destroys ozone. Now we have seen that sometimes this ClO will react with this NO2 and it will give us a stable compound. This compound is called chlorine nitrate. Similarly, this chlorine will react with another compound, that is methane, which we have just seen, and it will again form a stable compound in our atmosphere, which is HCl. And both of these compounds are stable chlorine compounds, that is, they do not easily release chlorine back to the atmosphere. So they are locked. The chlorine is locked in these two compounds so that it cannot react with ozone again. So this is the natural process of removal of chlorine from the atmosphere. So what are the sources of chlorine in our atmosphere? There are both natural as well as man-made sources. So we know that there is a lot of chlorine in our oceans. So these oceans, during these waves, they spray a lot of chlorine in the atmosphere. Similarly, the volcanoes also emit a lot of chlorine in the atmosphere. Industrial cooling as well as domestic cooling, it releases this chlorofluoro compounds in the atmosphere. These natural sources of chlorine, they get dissolved in water and they come back to the earth. But these CFCs, they are very stable. They do not react with water or rain, and they remain suspended in the atmosphere. It takes them around 1 to 2 years in which they reach the stratosphere. In the stratosphere, we know that there is high intensity of UV rays. These UV rays, when collide with these chlorofluorocarbons, we see that a chlorine ion is released. And thus, this chlorine ion from these CFCs become the source of chlorine in the stratosphere. And there is no natural process for removing CFC from the atmosphere. So that is why the CFC compounds become a major threat to ozone layer. So all this discussion brings us to the most important topic, that is how a ozone hole is formed. So every year during the month of August and September, which is spring season for southern hemisphere, we see that ozone holes are formed over Antarctica. So we will try to understand what is the mechanism by which these ozone holes are formed over Antarctica. So the first question, you may think that chlorine is released in the urban centers or the industrial areas. Then how can it reach the polar regions? The answer to this is that there are air circulation cells in our atmosphere. We can see that these are the air circulation cells in our troposphere, while there is a one single celled circulation in our stratosphere, which is very slow. So because of all this mixing, even if you produce a chlorine over here, over years it will be carried to the poles, because there is continuous mixing of gases going on in the atmosphere. Now the stratospheric clouds play a very major role in ozone depletion. So please try to understand the process of formation of polar stratospheric clouds and what are the effects of the formation of polar stratospheric clouds. So we have already studied in our previous videos that vapor does not cross the tropopause boundary. It is generally confined to our troposphere. But then how come the vapor reaches the stratosphere? So there are two mechanisms. Some of the vapor, it comes from troposphere. We know that there are a lot of very heavy cyclones. There are other processes through which some amount of vapor from the troposphere can go into stratosphere. The other major source of water vapor in stratosphere is the methane reaction with this hydroxyl. We see that this reaction gives us water in the output. And this water plays a major role in formation of stratospheric cloud. Now here we can see that this is a month of June, and we can see that there is complete darkness in the Antarctic region. We can see that no sunlight reaches Antarctica. You can see that there is a winter night going on in the Antarctic region. Now because of this, what happens? The circumpolar current which flows around Antarctica, it becomes very strong. It becomes so strong that it reduces or diminishes the mixing of water from the tropical oceans to the Antarctic Ocean. You can see that there is a very rigid boundary formed over here, and this will not allow mixing of hot water with cold water. Therefore, the cold water is confined over here. It cannot go anywhere, and therefore we see that the temperature drops in the Antarctic region. Similar mechanism occurs in atmosphere. We can see that the polar jet stream, it becomes very strong in the upper troposphere, and even this prevents mixing of air from the hot regions, that is a tropical region. So whatever air which comes from here, it cannot reach the Antarctic region. We can see that a kind of division is created, and all the cold air is confined to the Antarctic region. And similarly, there is polar vortex moving over the Antarctic in the stratosphere, and these are also very strong currents, and they also prevent mixing of hot air from the tropics with the cold air in the polar regions. And because of this, we can see that a sustained, very long cold climate is formed in this region, because no heat can reach from the tropics to this place. The temperature drops to -40, -50 degrees Celsius. Now because of this, we see that stratospheric clouds are formed by condensing of the water vapor. We have seen that there is water vapor in the stratosphere. We know that for formation of clouds, there is a requirement of hygroscopic particles. But here, there is no hygroscopic particles. But because the temperature is so low, it is around -40 to -50 degrees Celsius, we see formation of stratospheric clouds over here. Now let's see what is the effect of formation of stratospheric clouds on these reactions which we have seen just a while ago. Here you can see the level of different compounds. This is their normal. This is a percentage variation. So this is not absolute equal, but this is their percentage normal amount in the Antarctic region. So now during the winter night, that is during the month of June, there is no sunlight. And when there is no sunlight, all these reactions which required photons from the sun, they stop. So you can see here that all these reactions have stopped. Now there is some amount of chlorine ion as well as ClO in the atmosphere. This will continue to react with NO2 and methane. Over the time we will see that this chlorine nitrate which was formed over here, it will reach and react on these stratospheric clouds. The stratospheric clouds will give them a base for reaction, and this reaction will separate the nitrogen and hydrogen, and we will get the chlorine compound over here. Now remember, these hydrogen and nitrogen elements are important for forming reservoirs, but by this reaction the hydrogen and nitrogen elements are removed. And now what happens, that because of formation of ice particles, these hydrogen and nitrogen elements will come down in the troposphere, and therefore we see that there is a depletion of hydrogen and nitrogen elements in the stratosphere, and there is an increase in chlorine compound. So we will see here that hydrochloric acid and chlorine nitrate amount is decreasing. We also see that NO2 amount is decreasing because NO2 does not only react with ClO and then it forms this chlorine nitrate which is removed, but it is also removed directly. You can see that NO2 directly reacts on this stratospheric cloud and it is removed by these ice particles. So we can see that there is a depletion of NO2. You can see by this bar over here, and there is a constant increase in chlorine molecule. So you can see that chlorine is added to the atmosphere by this reaction. Now in a similar manner, the methane amount will also decrease. The reason is that no additional methane comes from the tropical regions, because we have seen a barrier is created. So whatever is there in the Antarctic region, that is depleted over time. It reacts to form this HCl, which again reacts to form this HNO3, which is released by these ice particles in the troposphere. So we see that there is a decrease in amount of methane, which is indicated over here. So we can see NO2, CH4, HCl, chlorine nitrate, all of them decreases in the winter month. But remember, in the winter, there is no decrease in the amount of ozone. The ozone is still at its normal level. Now, with the arrival of spring, we see that the sunlight will come from the horizon. There is very light sunlight which is coming from the horizon, which you can see over here. Now, because of this arrival of sunlight in the spring, we see that all these photodissociation processes which were stagnant will now start. The HV rays will dissociate chlorine atom into chlorine ions, and we can see now the concentration of chlorine molecule decreases and chlorine ion increases. And this chlorine ion will react with the ozone in the Antarctic region, and it will reduce the amount of ozone in the atmosphere, and there is drastic decrease in the amount of ozone. So now you can see that in spring, that is when there is partial sunlight available, we will see that the ozone will decrease. So it does not decrease during the winter season when the chlorine compound is formed, but it decreases when there is marginal or partial sunlight reaching the Antarctic region, which starts this photodissociation process. You can see that this is the photodissociation process where the photon is used to dissociate chlorine molecule into chlorine ions. Similarly, here ozone is divided into oxygen ion and oxygen molecule. So this process starts in the spring month. Now what happens as the time passes, we reach in the southern summer season, that is in the November and December, where complete sunlight reaches the Antarctic region. We can see now that there is a 24-hour sunlight in this Antarctic region. Now in the month of summer, when very strong sunlight reaches the Antarctic region, we can see that these stratospheric clouds are destroyed. Remember, for the formation of stratospheric clouds, we required very cold atmosphere. But with the arrival of sunlight, the cold temperature that was around -40 to -50 is removed and temperature rises up, thus destroying these stratospheric clouds. and therefore the balance is again reached, and we can see again that all these molecules are to their normal level. But repeated cycles as well as increase in the amount of chlorine can reduce the ozone layer, which cannot be repaired or which it cannot attain back. So that is why there is serious concern regarding chlorine molecules or chlorofluorocarbons. I hope you liked our video, and if you have liked it, then please do not forget to subscribe and press the bell icon. Do follow us on Instagram as well as Facebook. Thank you.